Mr. Akhilesh Prakash Gupta, Organizing Chair of PERA 21. Welcome, Akhilesh. We are very grateful for all of you to have accepted our invitation to be part of this elite colloquium. Now, I'd like to invite Mr. Akhilesh Prakash Gupta to deliver a convivial welcome speech. Please, Akhilesh.
Hmm. Thank you, Atul. First of all, good morning to all. I would like to start with welcoming our honorable guest, Professor A.R. Haris and Professor Satish Kumar Singh. Thank you for accepting our request and sparing time from your busy schedule. It is an honor for us to have you here. We heartily welcome you, sir. I also would like to welcome Dr. Ankush Sharma. From the inception of the concept of PERA 21 workshop, Sir has been always there for us, providing his valuable guidance. I express my gratitude to all speakers for accepting our request. We know that it takes a lot of efforts to prepare and deliver a discourse. The organizing team is highly obliged to all the speakers. We welcome you to this event. Any event is incomplete without its participants. Initially, our target was 50 participants, but thanks to enthusiasm of you all, today we have 108 participants from approximately 30 different institutes, including IITs, NITs, universities, and private institutes. We welcome all the participants for joining us here. Now, I would like to take this opportunity and give a brief information of the event. Power Engineering Research and Application, commonly known as PERA, is a flagship event of IEEE PES student branch chapter of IIT Kanpur and the IEEE PES Uttar Pradesh section chapter. This workshop is managed entirely by student volunteers, and its first version was held in November 2018 at IIT Kanpur campus. The preparation for PERA 21 started back in January with an aim to uncover several present day and future challenges related to microgrid. This time, due to ongoing COVID situation, we are organizing it in virtual mode. But this has also helped us to reach and get benefit from a greater number of resource persons and participants. The workshop is supported by IEEE student branch of IIT Kanpur and the IEEE Uttar Pradesh section. We received sponsorship from IEEE Uttar Pradesh section as well as industries like Typhoon HIL, Quabj Infosystem, and Opal RT Technologies India Private Limited. The UI Assist is a technical sponsor of this workshop. This 5-day workshop includes total 10 sessions with one morning and one evening session on each day. It has 9 expert lectures, 3 industrial talks, IEEE session, and panel discussion. I'm delighted to share that we have 7 foreign and 9 Indian speakers, as well as experts from industries like Typhoon, HIL, Opal RT, and Siemens. At the end, once again, I welcome you all and hope for a great success to PERA 21. Thank you.
Thank you, Akhilesh.
Yeah.
Dr. Ankush Sharma obtained his BTech degree in electrical engineering from Harcourt Butler Technological Institute in 1998. His MTech and PhD degrees from IIT Kanpur in 2001 and 2014, respectively. He has worked as a research scientist in Tata Consultancy Services and Wipro Technologies. He joined IIT Kanpur as an assistant professor in the Department of Electrical Engineering in 2018. where he is presently an associate professor. May I invite Dr. Ankush Sharma to address the gathering? Sir, I kindly request you to share your thoughts.
Thank you very much, Atul and Akhilesh, and good morning to all of you. On behalf of IEEE PES UP section chapter and IEEE PES student branch chapter, a very warm welcome to all the participants who have gathered here to listen to the various aspects of the microgrid in PERA 2021. Now, microgrid is indeed going to be a game changer in the distribution system, and it has gained importance, particularly from 2012 blackout onwards, because people thought about the flexible interconnection of the distribution systems, where microgrid plays a major role. Now, microgrid also poses a lot of challenges because we are now integrating renewables extensively at the distribution level. So the protection and other stability aspects are also going to be there, which is going to be a research as well as industry application topic to solve. So basically, we will discuss the various technological challenges and the aspects which we are facing in microgrid implementation. And we will also see that what is the future of microgrid and what will be the proposed shape of microgrid when we go forward. So indeed, this particular workshop is going to be a really eye opener for a lot of people who are interested in working in the microgrid area, especially the researchers, because this is a very hot research topic as of now. And a lot of challenges we are seeing in the microgrid implementation. And I hope all of you will enjoy the various lectures which will be delivered by various experts during September 24, that is today, till 28th September 2001. Finally, again, welcome all of you to this workshop, and I hope you will enjoy the learnings of the future perspective of microgrid. Thank you very much.
Thank you, sir, for such a brief introduction and your perspicuous speech. Dr. Satish Kumar Singh obtained his BTech degree from RML Awadh University, Faizabad, UP in 2003, his MTech degree from Devi Ahilya University, MP in 2005, and his PhD degree from JP University of Information Technology, Himachal Pradesh in 2010. He joined IIIT Allahabad in 2013. Currently, he is an associate professor at IIIT Allahabad. He is also the section chair of IEEE UP section and a member of IEEE India Council. May I invite our guest, Dr. Satish Kumar Singh, to say a few words and address the gathering. Sir, I kindly request you to address everyone.
Thank you, Atul, and thank you, Akhilesh, for inviting me here to discuss something, to know something more about this particular event. I was very much curious about this event because we heard many things, and we experienced that IEEE, Power Engineering Society, student branch chapter of IIT Kanpur is very active, and in past accumulated many awards as well. So this is well known. So it's my belief that from section side, it is our responsibility to promote, not promote exactly, to support these kind of activities, because this activity will be really hand-holding for the institutions and the students who are little resource deprived in terms of the technical know-how, as well as some other maybe laboratory resources and many things, where through this activity, students and participants will get a chance to interact such an eminent persons who have been invited in this particular workshop, so that in future, if these people connect and these people are interested, then definitely our student members in Uttar Pradesh as well as Uttarakhand section, Uttarakhand area will also be benefited. So really, this is a great initiative, and I'm really thankful to IEEE Student Branch IIT Kanpur and PS Student Branch Chapter of IIT Kanpur, just to create a vibrant environment. And this is really a motivation for other institutions as well. Because if good activities are there in the section, it adds some value to the IEEE membership also. So really, people will be connected, and we are very hopeful that in future this event will be expanded like anything. Here I can observe that there are many eminent speakers. So there are 12 sessions, 9 eminent speakers, 3 industry persons, 7 foreign speakers. There are more than 100 plus participants. So this is a huge activity. It is better than some good thematic conference. So it's my suggestion, if it is possible, then it can be expanded as a good activity. And there may be some round table kind of conference where there may be very little, very few invited papers, those can be discussed, and further some good quality IEEE transaction, etc. can be targeted. So this way it can be expanded and can add more value to this particular activity. With these things, my best wishes to all of you for holding such a wonderful activity. I'm really thankful to Ankush Ji for guiding you people. He is very able leader, and it's great that you're getting these kind of people in your kitty.
Yes, sir.
I'm really thankful to Professor Harish Ji. He's always there whenever we used to conduct any activity, maybe even XCOM meetings, etc. Every time we got support from Professor Harish Ji. We are really thankful to our mentor and our ombudsman here in IEEE XCOM, Professor S.C. Srivastava ji. He's always there to help and guide all of us. So we are growing, the section is growing. And all of you, this is just because of the contribution of all the members, whether it is the student member, graduate student members, professional members, senior members, and fellows. We are very fortunate that we are having 4 fellows in our kitty. Thank you very much for inviting me and providing me a chance to just to have the glimpses of this particular activity. Thank you.
Thank you, sir, for your motivating words and expressing your thoughts with all of us. Professor A.R. Harish obtained his BE degree in Electronics and Communication Engineering from University of Mysore in 1987. His MA degree from University of Roorkee in 1990 and PhD degree in Electromagnetics from IIT Kanpur in 1997. Between 1997 and 2002, he has worked with different industries in India and abroad. He joined IIT Kanpur as an associate professor in Electrical Engineering Department in 2002. Currently, he is a professor as well as Dean Research and Development at IIT Kanpur. May I invite our guest, Professor A.R. Harish, to say a few words. Sir, I kindly request valuable thoughts with all of us.
Good morning. Thanks, Atul. Professor Srivastava, Professor Satish Singh, Professor Ankush Sharma, and Professor Soumyaranjan Sao, and Akhilesh. Thank you for inviting me, giving me an opportunity to say a few words. Impressive, very impressive. A great learning opportunity, I'm sure, Para 2021 or 21. Learning is not complete unless it is associated with creativity. I'm sure this gives a grand platform for you to learn the fundamentals and techniques and challenges of microgrid. But what I'm expecting from you people, most of you people, is that please be creative. Come up with your own solutions, new solutions. I reciprocate what Professor Satish Singh said. If you are able to come up with new ideas, then you'll be able to publish. And that will be a real nice stepping stone for research career. To augment the research careers, to support the research career, we require a structure, an ambience, an environment. And I strongly believe IEEE provides that ambience. I hope, I'm sure, many of you are members of IEEE, but those of you who are not, my sincere request, please, become members of IEEE. It is not very complicated. I'm sure Akhilesh and Atul will be more than happy to help you,
Yes.
guide you how to become members, and
Yes, sir.
let this be a start of a new chapter in your professional career. I wish you all a very enjoyable experience. The way I see the programs have been scheduled, one in the morning, one in the evening, to suit people across the globe, across time zones, as well as those who are professionals. It's a brilliantly planned event. So I'm confident that you will make best use of the resources and the knowledge that is available in the platform. Thank you once again. Wish you all every success and enjoyable experience. Thank you.
Thank you, sir, for providing us such an inspiration and your lucid speech. Dr. Soumyaranjan Sahu obtained his BTech degree from University College of Engineering, Burla, Odisha in the year 2008. His MTech and PhD degrees from IIT Bombay. In 2013, he joined IIT Kanpur as an assistant professor in the Department of Electrical Engineering in 2014, where he is presently an associate professor. He also serves as a vice chair of IEEE PES UP section chapter. May I invite Dr. Soumyaranjan Sahu to deliver vote of thanks. Sir, I kindly request you to present the vote of thanks.
Thank you, Atul. So this nice event has been happening for, I think, past 2 or 3 years, with possibly obstruction in the last year due to some technical issues and COVID. But it's nice to see that this is back on track. So, and this event would not have been successful without the IEEE PS student branch chapter of IIT Kanpur, because they initiated it for this year. I also thank IEEE UP section in general for actually sponsoring this event, and our industry partners, specifically Typhoon Hill with Quas Info Systems and Opal RT Technologies India Private Limited for sponsoring this event. I thank Professor Srivastava and Professor Ankush Sharma as the PIs or the lead PIs for the UI Assist, which is currently the technical sponsor for this particular event. I also thank Professor Satish Singh and Professor A.R. Harris for finding out some time to address this gathering here and inspire them to be a part of this, and also continue the ideas that they have collected from this particular event at the end of this event. So I hope that everyone has something to gather from this event. And finally, as Akhilesh said, that we have a good number of participation this time. So this event would not be a success without the involvement of the participants as well. So I thank you for showing your interest in this particular event, and I again hope that you all have something to take away from this. And at last, I would really thank all the speakers that have actually agreed to be a part of this particular event and help this community understand the nitty-gritties of the upcoming concepts of microgrids. Thank you.
Thank you, sir, for delivering such an appreciative vote of thanks to our dignitaries. So with this, we have come to an end of the opening ceremony of PERA 21. Now, it's time to proceed with the workshop with the inaugural lecture by Professor S.C. Srivastava. Professor S.C. Srivastava obtained his BTech degree from IIT BHU, Varanasi, and his PhD degree from IIT Delhi. He joined IIT Kanpur as an assistant professor in the Department of Electrical Engineering in 1988. Currently, he is the director at IIT Kanpur, La Trobe University Research Academy, and a distinguished visiting professor at IIT Kanpur. He is a professional member of several societies and organizations, which includes INAE, IEEE, Institution of Engineers, IETE, and IAMMS. He is also a life member of Systems Society of India and Society of Power Engineers of India. May I invite our guest, Professor S.C. Srivastava, to present his lecture. Sir, I kindly request you to please present your talk.
Thank you, Atul and Akhilesh, for inviting me for this lecture.
Yes.
I think I am the one person who has witnessed the evolution of IEEE UP section, and also first two chapters, they were joint chapters which were launched in 95 when I was the chairperson of the IEEE UP section. One was the joint chapter of the Power Engineering Society and Industry Applications, and other was, I think, Communication and Signal Processing. And we had one research interest group on neural network, which became, I think, regular society later on. So that was the time, I think, we were not sure about how successful it will be, but looking at the progress till today, and specifically this particular conference, I'm really excited that whatever seed we had sowed so at that time has really grown into a big tree. And I think it will keep on growing in coming days. So I would like to congratulate the IEEE IIT Kanpur student chapter and also PS chapter of UP section for organizing this particular conference. And we are witnessing the success of this particular conference. So when Achilles came, he said, you have to talk about microgrid. I said, I'm not sure whether I can make some slide. Then yesterday night, I became Hanuman and prepared 29 slides. So, but I'll try to cover in the given time slot. So it is a few concepts of microgrid. I will also touch upon the issues, and specifically addressing the challenges of the renewable energy system integration in globally. I think that everybody is aware of that. Now, coming to the, okay, what has happened? Yeah, so I mean, content is not very big. So I'll give you a glimpse of some recent changes in power sector, then growth of renewables to address environmental concerns, few challenges with the renewable integration, microgrid concepts, and applicable standards. And UI Assist, we are implementing 5 of the microgrids in India itself. I would like to briefly touch upon them and finish with some concluding remarks. Now, we are passing through a very exciting period in power sector, actually. A lot of changes are coming place. So whether you say it is 4th or 3rd industry revolution which has come up, but as a power system engineer who used to be very conventional, dealing with the lines and power plants, now they have to get transformed into learning into the IT-enabled services, the communication system, the knowledge of the even cyber security aspect, new materials, and so on. So the power sector globally has seen a lot of challenges. One of the big challenge which came is because of the global environmental concern, and that is causing the temperature rise. Actually, there is a body called as Intergovernmental Panel on Climate Change, and they do a lot of research and predictions with respect to the climate change which is happening globally. And they have predicted that if we don't do anything, our global temperature is going to rise by 1.5 degree in the coming century. So you have to do urgently something. 1.5 degree centigrade looks a little smaller figure, but the impact is large. I think many places in the world like Venice and maybe some part of India or Bangladesh, they will go into the sea if this happens. And the glacier will melt. All those things are known. Now, one of the major contributor of the greenhouse gas, which is causing this change to take place, is the carbon dioxide gases, which predominantly is produced by the power sector, the transport sector, industry sector, and so on. So they are addressing this global challenge by doing transformation in the power sector as well as other sectors. So going ahead with a lot of renewables sources. The other pressing reason is that we are going to be very short of the fossil fuels very soon. So we are going to exhaust it. That is the prediction. I don't know whether it's correct or not, but that is another reason. Now, this along with new power electronic devices, sensors, information technology, and IT-enabled services, which we are embedding in our existing SCADA system. We have created with the help of synchrophagers, this wide area monitoring system, and everybody talks about the smart grid, where this microgrid is a part of a smart grid revolution, which can be off-grid or grid connected. And many changes are happening because of the revolution in materials, I think. We are talking about nano, composite, polymeric, and superconducting material, which are finding place not only in power sector directly, but also in electronics and microelectronic circuits and so on. And on the top, because we have opened the electricity as a market, so the regulatory changes are coming up very fast. Now, there are some global predictions. I think if you search through Google, you'll find many reports. One of them is by an US Energy Information Administration, which is actually 2019, that is the latest available. Now, they have predicted a large growth of renewable until 2050. Why 2050? I'll come a little later. And if you see the energy uses, the power generation is also quite significant. Energy required to generate the power is quite significant as compared to all other uses. So slowly the coal and other sources will not be used that much, whereas renewable share will increase. Here they are talking about in terms of the calorific value, which is in British thermal unit, and this is the conversion in kilocalorie. And quadrillion is actually 10^15, so you can get some idea. So there is a global efforts with the help of renewable sources and also making it sustainable and green. And everybody talks about decarbonization just to address the global environmental challenge. There is another agency known as IRENA, which is International Renewable Energy Agency. I mean, a lot of companies from India and institutions are part of this IRENA. And they have given a roadmap in 2021. There is a report published June itself. How we are going to tackle this 1.5 degrees centigrade rise problem. So they say that you have to make it carbon neutral by 2050. How do you achieve? With large penetration of renewable, at least in power sector. So other sector also they have to address. So if you see the share of power and heating plants, that is going to be major in reducing the carbon emission. This is in gigaton equivalent of carbon dioxide, 13 gigaton. So that much you have to reduce by 2050. And they propose that all the coal plants should be shut down. I don't think India will agree. To make ourselves sustainable, we will retain our coal-based power plant and thermal power plant. So this is the prediction they have given. Now, this is the share they have predicted that as of they have compared with 2018 as the baseline, where renewable energy share was 25%, but this includes all the biomass and biogas and so on. Whereas the variable renewable energy, which is predominantly solar and the wind, their share have been 10%, and that will rise to 90% and 63% in terms of the energy generation. And in terms of capacity, it will rise to 92% and 74% respectively. So they say if you achieve this, then only you can save the earth from the global climate change. Now, India also, we have very ambitious plan of adding the renewables. All of you may be knowing 175 gigawatt by 2022 and 450 gigawatt by 30. Almost half of that we have achieved so far. So I don't know whether, sorry, not half, about 3/4 or so, 2/3 or 3/4 we have achieved so far. So we have to make effort in bringing this figure by 2022 to 175 gigawatt. Solar, we have planned for 100 gigawatt, but we have reached 44 gigawatt. These are the share of the other sources. So you see here the coal and the other thermal generations are predominant here. So coal itself is about 54% share. Now, if we analyze, this is the, map of India, but it is not broken. This is only for the sake of clarity, because it has been electrical management is done by through 5 regions. So these are the northeast, southwest, and northeast region. These are the transmission capacity. We are very good at transmission network, and inter-regional transmission lines are there. But if we analyze the percentage share of renewable energy with respect to total installed capacity in every region, so northern region is about slightly more than 20%, western is close to 25%, southern is very high, and predominantly because of the wind actually. So India is actually 5th largest in wind. So it is close to 40%. And well, islands, we have to go for a lot of renewables. So I'm not surprised if this figure goes to 70, 80%. So because you have to survive like a off-grid electricity system. So this will be quite high. So places like Andaman and others, a lot of renewable have to be added. So, but the value is very little so far. Even eastern and northeastern region, it is quite less. Now, this poses a lot of challenges. If you have a lot of renewable and if you don't talk to other regions, then management of the variability of these renewables becomes very, very difficult. I'll touch upon them a little later. So there are sources like wind and solar, which depends on season, weather, and then daytime insolation level of the sun. Then they are very variable generations. Now, if they are keep on varying, just imagine that 40% of the generation in the southern region that goes off because the wind is very low, velocity is very low. Now, how will you balance the power? So you need very, very strong power balancing mechanism. We should have very flexible generations also present in the system. So they talk about flexible generation. Then once you put these, then voltage and frequency control also becomes quite challenging, because many sources do not have reactive power generation. Like if you put most of the wind power plant, they are using induction generator. Solar produce only real power. So how do you manage the voltage required? How will you control the frequency? Then if some generation is lost, like the example I said, because of the temperature variation, a lot of cloud came, solar is not absent, or the wind velocity is low, or it is too high, then also you shut down. Then it will lead to instability problem. And it gets compounded because some of these sources like our solar, they do not have any inertia. They don't have any rotating part, whereas inertia helps in maintaining the stability. But we are also using a lot of power electronic components. The problem of harmonics, flicker, voltage right through capability requirement will rise. But thanks to power electronic circuit controls, they can be easily handled. And then you would like to extract maximum power because it is almost free from operating cost. Now, one good solution to address the variability is the energy storage, which everybody is talking. And this is broadly classified into 4 types. One is mechanical type, pumped storage, hydro. We have limited deployment of pumped storage, but large deployment is required. I think government is going ahead with this. Compressed air, I think European countries have gone ahead, but I don't know why India has not thought about that. So this also is a good solution, but this needs a lot of ground space. So that can be created. I think the empty space which is left behind after some mining is over, underground mining is over, can be very efficiently used for this purpose. Flywheel for smaller power applications are successful as of today. Electrical storage, SMES, and supercapacitor. Supercapacitor is very good for handling transients. So, but again, they are costly. Large scale deployment is not possible. only specific deployment is there. Now, in future, we are talking about hydrogen economy. So I think fuel cell application will grow. So, but this is under research stage. There are a few fuel cell already available, but they are limited capacity. What is successful is this electrochemical for medium power applications, including those applications in microgrids, which may be up to a few megawatt, not gigawatt. Lead acid is a very established technology. The advanced lead acid, which is gel-based batteries, maintenance-free, is one of the good solutions, cheaper solution. Research is going on in the sodium-based and zinc-based. Flow battery again is picking up, but lithium-ion has also become very popular in microgrid applications or the EV application. For microgrid kind of application, the lithium ferrophosphate is popularly used. For the EV application, NMC technology, nickel magnesium carbon-based technology is being used. Now, let me take example of wind and solar. What are the challenges they independently pose? So wind speed prediction, you need to accurate forecasting tool, power management tool, synchronous operation because they normally employ the non-synchronous sources of generation. That is possible through good power electronic interface and controls. Active power and reactive power. Well, reactive power, if it is induction generator support is not there, they will consume reactive power. Then how do you address that? Maximum power point tracking is applicable everywhere. Power quality issues, which is complying with IEC and IEEE requirement. These are some of the examples that turbine should stay even under fault. Plant to supply required real and reactive power to recover voltage. And then if it is, we are also talking about offshore wind power plants. Then how do you bring the power to the shore, onshore? That is also a challenge. People are talking about HVDC light or that kind of link, lower voltage HVDC light link. So these are some of the challenges. Normal induction generator cannot support the voltage at the terminal. It cannot produce reactive power, but if you go for DFIG kind of generator, through proper control, it is possible. Now, coming to solar quickly, its output depends on solar irradiation, temperature. Again, it needs very good forecasting. So one important tool required in managing renewable is the forecasting, very accurate forecasting. Then partial shading problem will come if cloud is there, partial cloud is there. Then you have, because it is a DC source, so if you are integrating to AC system, DC-AC interface, with voltage and power control and ensuring maximum power tracking. It has no inertia, no reactive power support. But fortunately, these power electronic controls, along with, I think, storage or without storage, they can provide the virtual inertia and reactive power support. So we are talking about the new class of inverters, which can provide the reactive power support. Now, then again, converters you have to properly select depending on the size and application. Reliable design has to be ensured, and its health has to be monitored, not only system-wise, but component-wise also. This I took from the Sandeep Anand gave me long back. And depending on the size of installation, let us say if it is a very large size, kilowatt or megawatt range, then we will go for central inverter, where three-phase supply we connect. But if it is a medium size, then we may go for a string inverter. So a string of PV cells connected to an inverter, that is the go. And then micro inverter along with each PV source, we have one inverter. This is very common in our houses where we talk about few hundred watts. So these are the different types of converters which can be used. Now, IEEE 1547 is one which I think anybody working in renewable integration has to look into more detail. But there are equivalent standards of IEC, and BIS has also brought out some standard after CA guidelines. So there are various versions which are available. 9 of them are listed here. The one which are not dark, they are under revision or going on. but there are many which are being followed, and they give standard for interconnection, interoperability requirement of the sources with associated electric power system interface. By the way, the difference between resource and source is that source are like wind and solar, but when we say resource, the storage is also included. Okay, that should be very clear to you. Then different aspect of renewable integrations are there, including information exchange, control, and so on. So this is the list. I think I will share this slide also to you. You can have a look at that. Now coming to microgrid. Microgrid, a lot of definitions are there. There are a few standard definitions, which I think one of the IEEE standard has given, that it is a group of interconnected loads and distributed energy resources with clearly defined electrical boundaries. But I will also add here that they are also having geographical boundary in a closed geographical boundary, and it may act as a controllable entity with respect to the grid. That means that even if the grid is not there, it will survive as an autonomous system. And if grid is there, then it will be able to successfully connect with the grid and operate in the grid connected mode. So both islanded and grid connected mode can be operated. But there are microgrids which are only islanded mode, where electricity grid has not reached. So that is off-grid microgrids. That is the definition. And then there are classifications of microgrid, like it can be deployed in campus, the strategic places like military installation, residential, commercial, industrial. It can provide premium power, continuous power, resiliency oriented, or it can be used for loss reduction, remote or grid connected. It can be, depending on what is the point of common coupling, whether it is AC or DC or combination of the two, it is classified as AC, DC or hybrid microgrid. So here are different sources, and the storage and loads are connected through various converters. And these are the perceived benefits. So one benefit is that even if the grid fails, you are able to survive most of the pockets if you have large number of the microgrids. Your dependency on the grid gets reduced. Other is you get continuous supply. It is being used for electrification and with the help of a very reliable supply. So villages and other places, it is very much applicable. And third thing is that if you are feeding the load locally, your load on the transmission network reduce. So whatever capacity is released, you can be utilized for feeding the growth of the electrical loads. So you need not add the transmission network. So these are some of the perceived benefits. Now, this is the structure showing with respect to AC microgrid, where connection of all the sources and storage and loads are at AC bus and DC microgrid. Now, I mean, one thing you should be very clear, DC microgrid, the voltage becomes very important. Here you have very standard voltage, but DC microgrid voltages are evolving actually. There are few voltages like 48 volt, 72 volt, 24 volt, which have been adopted in India. Why they have been adopted? Because the safety problem is not there. I think the safety is there with respect to these smaller voltages. So even if you touch, nothing happens. Don't try to touch it. But if you want to transmit more power, or you have larger sources and larger amount of loads, you have to properly select the voltage. And that is where challenge starts. So DC has certain advantage. No reactive power problem. No frequency control, you do not bother. Synchronization becomes very easy. With the help of this power converter, you can easily synchronize. But the protection becomes the biggest challenge. Okay. In fact, the voltage control is through utilizing the real power output of various sources. So P and V control is there. There is no Q present here to control the voltage. Whereas here you have to worry about frequency control, reactive power, voltage control is possible. But this is very standard system. All gadgets are available, so you can easily implement. So there are relative advantages and disadvantages. Now, But challenges, which I think becomes a research topic, is that how do you stabilize the voltage in either AC or DC through proper converter controls design, synchronization in case of AC, power management and power quality management in both of them, frequency control in case of AC. Protection, it is more challenging in DC, but you cannot ignore in AC also because it may have bidirectional flow. So your protection has to be designed that way, either directional protection or the adaptive protection. Stability issue, particularly in AC, but voltage stability is very much there in DC also. Grid integration issue and islanded operation. So safe islanded operation also should be possible, detection of island and operation. Now, the microgrids are provided with different levels of control. This is a very standard size we share. Primary control is the converter level controls, where you can have also embed the droop control. So depending on the droop value, they share the real power. Like depending on the frequency droop, the conventional grid shares the power. It's similar to the governing control. And then the secondary control is basically the power sharing between different sources and also the optimal management with respect to your the storage, looking at the load value. So there's some kind of communication or the distributed control philosophy is there. Then tertiary control, if you have several microgrids of this nature, their respective scheduling is required, coordination is required, volt-hour control is required. So that is done normally at the control center, where distribution management system or advanced distribution management system is really provided. So these are the three levels of controls. There are a few more standards. I think I'll just show the list. Microgrid controller specification is given in 2030.7, from where I took the definition also. And this is the interoperability standard and also giving the IT operation and electric power system requirements. And there are many other IC standards for looking at different aspects, like protection aspect in this one, then energy management system aspect in the second one, technical requirement for self-regulation dispatchable loads in the third one. Virtual power plant is the one. Virtual power plant is a new concept. This whole microgrid can act as a virtual power plant. So this whole entity can sell power to the remaining system as if it is acting as a virtual power plant. Okay. Although internally it has different sources and loads. So, but to the system, it looks like a virtual power plant. So that is also some standards out there. Now, coming to the Indian side, a lot of regulatory and policy changes have taken place to promote the renewable energy. There are certain tariff policy and like renewable purchase obligation, generation obligation, then exemption of renewable energy from interstate charges. No tariff is provided on them. Then cross-border trade provision, then intra-state balancing, and then including a communication in power sector, some certain regulatory framework have been brought out. So India has done a lot of exercise with respect to promotion of the renewables. Now coming to the next one, I'll just briefly touch upon what kind of microgrids we are implementing in our UI Assist project. And UI Assist, this is the full form given. This is with the help of funding from on India side from DST through Indo-US Science and Technology Forum, and US side it is the DOE. There are 15 consortia members involved from US and 14 from India, including several academic institutes. We have 5 IITs here: IIT Kanpur, IIT Madras, IIT Delhi, IIT Roorkee, and IIT Bhubaneswar, along with TERI. And then we have the NTPC Netra, Power Grid, BACS, Uttar Pradesh Power Corporation. Hello? Hello? Okay. And then similarly, a lot of academic institutes from USI, WSU, the Texas A&M and Hawaii National and MIT, and few government labs and utilities and industries are involved. So it is a big consortium project of 5 years. Now, we wanted to evolve the model of the future distribution grid, which will not only embed the renewables and the storage, but also various types of microgrid. So there are 5 field pilots planned in India and 5 in US under rural, semi-urban, and urban microgrids. So in India, we have 1 rural, which is coordinated by us, 1 semi-urban by us, another semi-urban by Netra, and 1 urban by us, and another urban by the TERI, along with the local utility BR. So I'll just quickly give you the glimpse of that. So how does the rural microgrid look like? So these are these 2 hamlets in Kanpur village, which is 45 kilometers from our campus. If you go to the Lucknow-Agra highway side, just before you catch the highway, about 5 kilometers before that, there is a place Uttaripura, and you turn left. About 3 kilometers once you travel, there is a village known as Harnu. And 2 of the hamlets, it has 4 hamlets, 2 of the hamlets were not electrified. So we selected it purposely so that we can electrify them and provide them reliable supply. Now we had a series of discussion with villagers, and then a social survey was done. And they said that not only electricity, but the irrigation is also the requirement. So we have put 3 solar pumps in each of the hamlets that we have installed. It is already operational. Now, looking at the local resource availability, we have planned our solar and the projected load requirement in those hamlets. So there are 85 houses in one Chabbanivada and about close to 75, 80 in the other one. So we have gone for the solar roof, solar plant, solar PV, 70 kilowatt in the Chabbanivada. And since the other hamlet has a lot of cattle, and it becomes very dirty, the cattle dungs are just lying on the street. So one best utilization will be to convert into electricity, collect it and convert it into electricity. So we have gone for this biomass system, 30 kilowatt and 30 kilowatt solar. Now, to make it sustainable, we have gone for 100 kilowatt hour, the storage system in each of them, which is lithium-ion, lithium pyrophosphate batteries are there. And then we are also providing them a street light. There's no power was there, so now a street light is being provided. So this is the arrangement. And ultimately it will be managed by a local society. So they will become single point consumer to the electricity company. The electricity company DVNL is also our partner, Dakshinanchal Vidyut Vitarani Company. So they have laid the wires as part of their contribution and also put the meter initially, which will be replaced by the smart meter. And ultimately the local billing will be done by the society, and single point billing will be to the utility. So that is the arrangement we have evolved. Already society is approved. So you see the complication. Management also becomes community level microgrid management also you have to work on. Now, to have surplus power flow from one hamlet to the other, we have also provided interconnection. So this is one first interconnected microgrid to best of our knowledge in India in this village. And just to take care of synchronization, we have gone for intermediate AC/DC converter. And everything will be controlled through a microgrid controller with Siemens supply. This is one. Now, second one is semi-urban we are calling, and it is in the 2 lanes of our housing complex where I'm also staying, lane 32 and lane 33. Single story, actually suburban area will have either single or double story, and you have availability of roof for solar installation. So we are installing 5 kilowatt solar PV at 30 of the houses where site is clear, along with centralized storage. So this is the substation where 2 feeders were going to these 2 lanes. This was the arrangement here through feeder pillar. Now through this storage they will be going. And this is one typical house the solar PV have been installed. As part of this project also we are putting 2 EV chargers. And they are having all kind of charger, fast charger, three-phase AC charger, single-phase charger, E to V to G and capability charger, which is three-phase charger. So one is being placed near the taxi stand, one of the gate railways crossing gate of IIT Kanpur, and second one is the community center type 2. We are placing. So they are also having 25 kilowatt solar power. So the local requirement can be met through solar, need not draw from the grid. Now, while we are designing, we have also looked at the metering and the production requirement. So if you, although it is not very much visible, certain places we have also placed directional relays to take care of the bidirectional flow. So this also becomes a very important factor even in AC micro. So this is semi-urban. Now, urban, there are two actually installations. One is with respect to 25 kilowatt solar and 50 kilowatt hour battery storage on rooftop of a multi-storage story faculty housing. There are two blocks we have taken, C and D. Similar installation we have made. And other is a thermal energy storage, which is also a relatively new concept. I think this needs more discussion. This tank has a is filled with glycol solution with some phase change material. The property of adding the phase change material is that even at -4 degrees centigrade, it remains liquid. So during night time when power requirement is less, the chilled water supply passes through this tank and brings the temperature to -4 degrees centigrade. And daytime when air conditioning load becomes very high, then this supports the air conditioning load of the building. This is in our environmental science building. I think IIT Kanpur people may be knowing. And this is running since last year, a very successful result it has given. So this is another kind of storage we have demonstrated. So here, critical loads actually we are able to survive in the night time even if storage is even if PV is not there and grid is not there, but daytime it can support the complete load of the blocks. So, and again, these are being controlled and monitored through microgrid controller. And all these three pilots which we are building in rural area and inside campus, they will be centrally monitored at our control center, and ADMS platform is being built. So for which will provide a tertiary control to these microgrids. Now I'll quickly show you the specification of what TERI is putting. They are demonstrating the capability of their microgrid is nothing but the deployment of storage system, lithium-ion batteries for different applications. One is to relieve the overload and reduce the losses in distribution transformer of the local New Delhi distribution system. Other is a gated community where diesel generator backup is there. They want to minimize that with the help of the storage. And third one, they have the solar also. This is their own campus, TERI campus, and they want to use the storage to make solar generation dispatchable and ensure the reliability of supply. And many other purposes they have planned, like energy arbitrage and so on. The third one, which is coming up, actually they originally planned rural microgrid, but it is a very big microgrid in Netra complex, which will have 4 megawatt solar and then 1 megawatt hour lithium-ion battery. They already have a municipal solid waste generator, which is of 400 kilowatt, and also a diesel generator. So they will do the optimal management. So this is at the ordering stage. So it will be over by next year end. So this is going to be a very big microgrid inside Netra campus. And they will provide controllers so that optimal management of different resources are possible, minimizing the supply intake from the utility. So that is the fifth one. Okay, so these are some of the examples of the actual microgrid which we are implementing, and the students are most welcome to see them and also contribute to similar microgrid in future. So renewable integration, just to conclude, renewable integration will pose power management, stability, challenges and proper controls are required. India actually has done a lot with respect to promotion of renewable. They have planned for a separate 400 kV and 220 kV line called as Green Corridor across the country to allow the seamless flow of these renewable energy sources, because they're very variable in nature. So some of the part may get overloaded and so on. They have provided a separate desk at the control center called as Renewable Energy Management Control Desk, and that is they are using for forecasting and management of various renewable energy sources. A microgrid concept will grow, and this has to be adopted at community level, strategic location, military also. Like if some terrorist attack comes, they destroy your transmission line, at least your strategic location survive. In US and many places, this kind of microgrid is very popular, being used. Industrial commercial complex also to increase the reliability. Then it has to be designed following relevant standards. There are certain guidelines given in these IEEE, BIS standards, CA guidelines, and controllers should also be designed for a smooth operation under both grid connected and isolated. Now, ADMS is a platform which has to be adopted at SCADA center in future smart distribution network development. And this will provide the tertiary control to microgrid also. Now, the very important aspect is that, well, we provide a system, but who will manage? Are the engineers aware of these technologies? So we have to train the utility engineers, not only engineers, but technician levels. We already conducted the training of technicians through our UISS project. 30 people have been trained. About 45 days training have been given. So that is very important. Next generation engineers and technicians have to be built. And then even if you go to community level deployment, awareness program has to be conducted to convince them that this is useful and then how to manage it. Okay, so a lot of challenging opportunities are there in future. I think the next generation people, students who are there in their program today will, I think, have to tackle the challenges, and all best wishes to all the student member of the IEEE UP section and also across the globe who are attending this particular conference. Thank you very much.
Thank you, sir, for such an informative and educating talk. Now, if anyone has any question, please feel free to post in the chat box. We already have one question from Jyoti Sharma.
Okay.
Is the biogas plant installation is working efficiently in producing electricity, which is installed for 30 kilowatt hour, and the biogas produced in that plant is used for any other purpose other than producing electricity?
Okay. So this biomass plant is under actually installation. So our rural microgrid is not yet ready. Because of the COVID, it got shifted by a year or even more than a year. So we are expecting by next month end, that is what the local contractor is saying, or not local, Siemens is saying. But I hope that by end of this year, definitely it will come. Biomass is the one which got delayed because of some contractual obligations with the agency which was implementing. But we have already lined up our local NGO, how to manage it. It will be used only for electricity generation, and also it will give very good quality manures, fertilizer, both liquid and as well as the solid manure. So we may probably go for a model where we purchase cow dung from them at some price and also sell the manure at a very reasonable price, much less than the market price. And the local management also will ensure that the electricity charges are quite reasonable and much less than what they are paying right now. Okay. In India, planning for 100% renewable is by replacing all the conventional renewable power. No, I don't think this is a very misnomer. 100% renewable is really a misnomer. what I think is that if load is X, that much capacity of renewables, if you can install, that becomes 100% renewable. Not with respect to total installed capacity. 100% renewable is theoretically possible if you have very strong storage or backup. Because again, you see a lot of variability is there. How will you take care of the variability? So even the arena write-up, they talk about gas and oil-based resources to survive, not the coal one. That is what they are saying. But again, India, we have, I think, deliberated a lot. Coal, we cannot close down the coal-based power plant. Nuclear is another option. I think if we could install a lot of nuclear, probably some of the coal can be retired. But nuclear is also very clean technology. But over the years, no growth has taken place. So 100% RES is not replacing everything with RES, to my knowledge. But you have to make it sustainable. I don't think that much storage we can provide. Looking at the technology, the availability of site is not really possible. Now, before go to next question, what percentage of the load in the institute is made by renewable energy resources? Actually, we already have 2.5 megawatt installation. Our campus peak load is close to 9.5 megawatt or close to 10 megawatt. We have purposely not gone for very high size because we want to avoid the reverse flow to the grid. That involves a lot of complication. The net metering has to be, approval has to be taken. But this particular project is not that big, so it is small. So 150 kilowatt in our suburban and then 50 kilowatt in the EV charging station, 50 kilowatt in the urban area. So that is the total 300 kilowatt from UI assist project. But the institute has gone for more than 2.5 megawatt. I wanted to know whether the state electricity board will allow to use their network as a standby mode after microgrid. Yes, they have agreed. We have agreed with them. So any power which is not met, they will supply, and they are ready to purchase the power also at net metering rate, which is lower, much lower than the actual rate. Yeah. So we have, because they are partner also, by the way. So we have agreement with them. How are we doing real-time demand side management on pilot project implementation through UI assist? Well, we are doing load management, not demand side management through UI assist project. Demand side we have demonstrated through earlier project, which was Ministry of Power Public project, which was the smart city pilot. Okay, so there were few houses which were provided with the storage and solar, 5 kilowatt storage and solar, and also the certain gadgets they were connected for home automation. So there this feature was there. That was a very limited one. But demand side management, yeah, that is the next step we can implement, I think. How will they decide? What is this? How will they decide their per day generator? It has to be it has to be, I mean, there is a monitoring also, but I'm not very clear about this question. There is a forecasting tool also we are building. You have given example of 2 villages. There are several rural areas which are facing similar issues, the low voltage issue and power system problem. So, sir, do you think there should be any startup company who should consider these problems? And there are many companies who are actually taking advantage of this situation. A lot of NGOs. In fact, last year itself, 2020 itself, India had about 100 rural microgrids. But their microgrid is very small size and without a very limited storage. So we have seen, myself and Ankush visited one microgrid in Sitapur. And what they provide is about 100-200 watts solar, and no storage was there. And they have given 1 watt, 2 bulbs to everyone and a charging point. And they are happy with that light because they had not seen the light. So I don't know, it was very pity, very poor people. So there are actually drives by certain NGOs and also Tata Power and many other companies also through their either CSR funding also. So, but pan India level, I think one has to decide. Rural Electrification Corporation has to decide what to do. Fortunately, the continuity of supply these days have increased, but the government also says 100% electrification is there. But as per their definition, if they install transformer in a village, which may have several hamlets, and if certain percentage of home gets electricity access, they say it is electrified. So even our village was claimed to be electrified, but there was no wire also. Okay, so in 2 hamlets. So hamlet level electrification, household level electrification, I think it is about 60-70% only. So that we have to address. I want to know what is the practical aspect of using micro PMU in practical microgrid. Yes, it has future, but it has to be low cost. And also it has to meet the distribution standards. After introduction of microgrid, how generation companies will change their generation at once as per demand. See, it comes to distribution. So the demand is growing. It's not that demand is not growing. So the generation will remain. But if you're talking about 100% renewable, then they're in trouble. So their plant load factor will reduce, utilization will be less. So, but I'm not seeing in immediate future there is a problem. So they will be loaded, actually, generators will be loaded. But distribution companies, if you go for such a microgrid, which are the locally owned, their revenue may reduce. So what US companies have done, they are installing on their own. In fact, we are volunteering that the local utility take over these ones and give a little subsidy to the villagers. So the complication of chasing them, how well you are managing will not be there. And they will be benefited actually. They have to procure less power to feed the electricity to their area and they get their own generation. But they are not agreeing. They say that we don't have qualified manpower and we have many other issues, internal issues. So, yeah. Anything else? I think I have covered all.
Yeah, we can stop. I think so.
Yes, sir. I think already the time is moving on, so we should
but
stop.
If you have any question, you can just send an email to me.
Yes, sir. That is fine.
Yeah. Okay.
Thank you, sir, for taking good time. Okay. Atul? Yeah.
Yes. So thank you, sir, for such an educating talk and for entertaining all the doubts and questions that everyone had. I thank you for that. Now we have come to an end of our morning session of day 1. I request you all to join the evening session at 5 p.m. again with the same Zoom link. The evening session will be about the typhoon hill simulation. Please stay with us for the rest of the sessions for the next 4 days. And I promise you that that you will learn something new from this. With this thought, I, Atul Soni, sign off. Thank you all.
Thank you, Atul. Thank you, Akhilesh, and
Yes,
everybody
thank you.
who have joined. Thank you very much.